Can you hear me now? Okay, you can hear now, right? Okay, okay, fine. And someone can speak so that I can know that I can hear you also.
Yes, sir, you are audible.
That is the problem, I cannot hear you. Okay, fine. If you, I think I cannot hear. Just write in the chat if you have any question, I think. Because when I on this recording, I cannot hear. Okay, I will just wait 1 or 2 minutes and I will start. And just 1 minute, can you see my screen?
Yes, sir, it is visible.
Can you just tell, can you see my screen? Okay, fine.
Excuse me, sir. Sorry to interrupt.
So let's start, I think. So I am Amit Ghosh. I am currently, I think, fine. Let me check. Okay, fine. So I am Amit Ghosh. I am currently in my PhD in IIT Kanpur. I am under PMRF scholarship, so I have to do this NPTEL TA duty. So in this course, first, like, I will discuss the previous year's half of the previous year's assignment. Like, this is your previous year assignment. So, like, you have two TAs here. So first half I will discuss, and second half tomorrow someone will discuss. So first four questions I will discuss, and in between some other questions related to this I will discuss. And if you have some doubts, just, I don't know, I cannot hear, but What chemicals? Okay, fine. I think I admitted everyone, right? Hmm. So let's start from the assignment from the previous year. So first is like these questions. You are given the norm of a vector alpha and and you have to find, if you are given x is this, then you have to find the mod of x. This is just an example they have shown. If alpha is, the norm of alpha is defined as root over inner product of alpha with alpha. Like, so you are given this norm, you have norm of alpha, right? Sorry. So here your alpha is given as x, right? And is given by I 1 and 2 minus I. And you have to find norm of x, right? That is given by root over x x. So let's do it. So first, if x is given by this, then you can write this as 1 I 1 and 2 minus I, right? Then your this thing will be, is it correct? This will be Dagger one, right? It is not correct. Can anyone tell, did I write correctly? So your x is given by this, right? Then your this bri is this, then ket will be, you have to take the Hermitian conjugate, right? Conjugate means there will be minus, right? This is thing, so this will be plus, right? Now this is correct. So then inner product of x is minus I 1 2 plus I 1 2 minus I. And if you do this, you will get what? Minus I square plus 1 plus 4 minus I square, right? Then this is 1 plus 1 plus 4 plus 1, which is 7, right? Then the norm of A, sorry, is given by root over 7, right? So this was your first question. So this will be root over 7, the first option. Okay. Sorry. It's fine. Now, related to this, I just want to write, suppose you want to write any state in the position basis, that you, how can you write the state? So the first thing is the difference between state and wave function. So if I write, so this is x, so this is a state, right? And what is state is nothing but some abstract quantity. So this is some quantum state. And if you want to know the wave function, then how you will get the wave function? The wave function you will get, you have to take the projection, right, onto some basis. Then you will get the wave function corresponding to this state. Understand? So suppose for notation, I just change the notation. So this is your suppose quantum state, and you write the quantum state as psi. So this is your quantum state. And if you not want to know the wave function, then what will be the wave function? You have to take the projection of this state onto the basis state, right? Suppose you want to know the position wave function, then you have to take the projection of this quantum state on the position basis. So this is your position basis, you take the projection, right? So this is your position wave function of this state, and this you write as psi x. So if you have the superposition state, right, in continuous basis, if you want to write, then you should write like psi is equals to the state will be given by so this is minus infinity to infinity. So in discrete basis, how you write? You write psi is equals to sum over n, suppose Cn into psi n, right? And in continuous basis, I will write the psi. If you have a superposition state, suppose in position basis, then this will be given by psi x dx, right? This will be your state in the position basis. State in position basis. And you can write the psi x. Psi x is nothing but the projection of this on x, right? So just write minus infinity to infinity. Psi x is given by x dx. Now from here, what can you say? Suppose you want to measure. Suppose you now want to measure the position. Then suppose your position operator is given by capital X cap. This is your position operator. Now if you act this position operator on this state side, then what you will get? Suppose you act this on side, but this will collapse the system to one of its eigenstate x, and it will have the eigenvalue. This is your, it will collapse here, right? And with eigenvalue psi x, right? And what is the probability of this collapse? The probability of this collapse is given by p is equals to this coefficient square, right? Mod psi x square. Also, you know that your total probability should be 1, right? So you can derive another thing is that integration minus infinity to infinity px dx should be 1, right? From here, what you can say, px is given by psi x square dx, right? This should be 1, and psi x square mod psi square means this, right? This should be 1. Mod psi square is psi star psi. So psi star psi you can write like this. This is psi star x. This is psi x. Psi star x given by this. Psi x is this. This should be 1. Right. Now you know psi. This inner product is 1 because these states are normalized. So we can write integration minus infinity to infinity x dx equals to 1. So this is your completeness relation. Okay, this may be important. Fine. So okay, next go to, I think if you have any doubt regarding this initial like psi vector or projection, you can just ask now. Next I will go to this density matrix thing. Fine. Do anyone have any doubts here? Like actually I cannot hear. So if you have any doubt, just write in the chat. I think. Okay, just one last thing just I want to say. Suppose you have this angular momentum basis. Okay, you know you have this L going from minus infinity to infinity. Then the projection will give the wave function in the discrete basis or continuous discrete basis, right? Suppose this is your angular momentum state, and you take the projection of psi on this angular momentum. L is discrete number, like some minus infinity to infinity it can go. So L can be 0, 1, 2, something like this. So if you take the projection of your wave function on this discrete basis, what you will get? Will get some number CL. Like this will give the projection in a discrete basis, right? And it will give you some complex number. Previously I showed you like here I take the projection in position basis. So you can take the projection of the same state on your position basis. This will give you what? Psi x wave function in position basis, right? This is the your wave function. So psi is the state and psi x is your wave function, right? So if you take the, so it depends in which basis you are taking the projection. If you take the projection on position basis like x, then you will get the wave function in position basis. Okay, and this is not a number, right? Previous case it was some number because it was discrete basis. Here you will get the wave function in position basis, and it's a function, not a number, right? Some complex function. Similarly, you take the same wave function projection on momentum basis p, then it will give you psi p, right? Wave function in momentum basis. function in momentum basis. And if your wave function, suppose psi is given, state vector is, so if your state vector psi is this, suppose some position basis, like, and if you take the projection on position basis itself, like, then what you will get, like, it will given by, suppose this is some x prime, this will be given. So x prime is nothing but Dirac delta x minus x prime. Okay, so this is wave function of the position basis vector. So Dirac delta of x minus x prime is nothing but, it's also a wave function of what, position basis vector. Because here your state is the position basis vector itself, and you are taking the projection on position basis itself. So that's why it is giving you the Dirac delta. So this is the Dirac delta of x minus x prime is nothing but the wave function of position basis vector. So that's the initial part. So if anyone has doubt, just ask anything in the chat. Write if you have any doubt. Next, I will go to this density matrix and pure and mixed state. Okay, fine. So let's go to the next topic. This is, so next is we have to write the density matrix for the superposition state given by psi. This. Okay, let me know. Psi is 1 by root 3 0. This root 3 0 plus I 2 by 3 1. Second question is, your state is given by psi is equals to 1 by root 3 0 plus I root over 2 by 3 1, and you have to write the density matrix corresponding to this state. So you write 1 by root 3, and the state vector 0 is given by, in matrix form, what 0 means, 1 0, right? And 1 means 0 1. So you write 0 like 1 0 plus I 2 by 3 0 1. So the psi you can write as, so if you add, then what you will get, you will get 1 by root 3, this is I root over 2 by 3, and now you have to write the density matrix. So if you write the density matrix, rho is given by this outer product, right, psi psi. So if you do this, what you will get, so psi is given by this, then get psi is given by this, then bra psi will be given by, this is 1 by root 3 minus I root over 2 by 3, right? If you do this, you will get 1 by root 3. This is I root over 2 by 3. To multiply these two things, right? If you multiply, what will you get? First term is 1 by 3. Second one is minus I root over 2 by 3 into 1 by root 3. Here you will get I root over 2 by 3 into 1 by root 3, and here you will get I root over 2 by 3 to minus I root over 2 by 3, and you will get 1 by 3. This is minus I root over 2 by 3 is I root over 2 by 3, and this is 2 by 3. So density matrix rho is given by this. So from here, can you say anything about, like, is it a pure state or mixed state? How can we know? Suppose I want to check whether rho is a pure state or mixed state. So what should I do now? You have to find not 0, you have to find a trace of rho is 1, right? For pure state, you have to check the trace of rho square actually, right? Yeah, trace of 1 for pure state, and you have to check whether trace of rho square is 1 or less than 1 for mixed state, right? Well, let's do this thing. So you can just check and square and check it. Just trace you will get, trace is 1, right? Trace of rho is equals to 1. So before this, just let me say what is the pure state and mixed state thing. Like, the pure state and mixed state. Why you need this mixed state thing or something? Like, suppose before this, just for example, I am telling the first situation. Suppose you are given a laser. So this is your mini laser. Suppose so some red light is coming from this laser. You are getting horizontally polarized photons is coming from these lasers. Okay. So photons can be horizontally polarized, vertically polarized, or plus 45, minus 45 degree polarized. Like, so from this laser, suppose horizontal polarized photon is coming, okay, and you put this to a beam splitter, okay. So what will happen? Some will go through transmit and some will reflect, like, and there is some mirror. It reflects and goes here, and the transmitted one goes through like this. Okay. Then you put another beam splitter here. So horizontal was coming. So after reflection, it will remain horizontal, right? It is also horizontal polarized photon. After transmission, it is also horizontally polarized photon. Right? And you put a suppose half wave plate. So the half wave plate will convert this horizontal polarized photon to the vertical polarized photon, right? So here now you have vertically polarized photons, and now you combine this incoming horizontal and vertical polarized photons into this beam splitter, okay, and you are seeing the output here. And so the output state, can you write what will be the output state? This output state, suppose psi. So you have just one laser, and from this one laser you are getting one. The laser is emitting horizontally polarized photons. First, this horizontally polarized photon is falling on this beam splitter. Okay, I am not telling the ratio later. Okay, fine. Suppose this is 50-50 beam splitter or something else. So the thing is, the beam splitter, some portion it's reflecting and some portion it is transmitting. Okay, so reflecting part then reflected by this mirror and going to the second beam splitter. So this is beam splitter 1 and this is your beam splitter or S or so, whatever you write. So this is your beam splitter 1 and this is your beam splitter 2. So in beams before, so the transmitting part horizontally polarized photon is going, then it is also reflected from this mirror, and after that you are putting a half wave plate, and the half wave plate will convert to vertical polarized photon, and both of them are combining in beam splitter 2, and you are seeing the output here. Output state you are denoting by psi. So the output state, what will be the output state? So can you write the output state here? I think the picture is clear, right? The output state you have to write. I actually cannot hear, so better to write. If you want, if you can write in the chat. So the output state here you can write like some portion of horizontal and some portion of vertical polarized photon will be there, right? So it will be given by some alpha H plus beta V. Now is this state a pure state or mixed state? Is this state pure state or mixed state? This output state? No, this is a pure state, right? Not a mixed state. Because all these photons, horizontal polarized or vertical polarized, is coming from a single laser, right? This is single laser. So they are phase correlated, like both are have same phase kind of thing, right? Or if if they have phase difference, then the phase difference is constant. It is not random kind of thing, right? So this output state is a pure state, right? Because this is also a coherent superposition. So this is a pure state. The output state will be a pure state here. Now the same thing you do with two lasers. Then you will understand what the mixed state is. Okay. Now instead of single laser, you use two lasers. So this is your laser 1. So laser 1 is giving you horizontally polarized. So ultimate you want to superpose the horizontal and vertical one, right? The first case you are using single laser and you are using two beam splitter and one halfway plate to superpose this horizontal and vertically polarized photon at the output. And the output state you write as some superposition of horizontal and vertical polarized photons, right? If this beam splitter is 50-50 beam splitter, then you will have the half, like alpha equals to beta equals to 1 by root 2. Then you can write, in this case you will have this still pure state, and you can write the pure state, right? 1 by root 2 h plus v kind of thing, and this is nothing but the 45-degree polarized photons. And the second case, suppose you are using, instead of one, you are using two lasers to get this horizontal and vertical thing. So first laser is giving, this is the laser 1. So from first laser you are sending the horizontally polarized photons, and from the second laser, this is laser 2, you are sending the vertically polarized photons. Now you combine them in a beam splitter, right? You use a mirror here. Mirror will reflect these vertical polarized photons, and they are combined in this beam splitter, okay? And you are seeing the output. So this portion is same, right? If you this one, so this portion I am keeping same because ultimately I want to see the output. Output means the superposition of this horizontal vertical polarized photon. The only thing in the first case, it was coming from a single laser. In the second case, it is coming from two different lasers, the horizontal and vertical one, right? Now here what will be the output state? Suppose I want to write the output state. Can I write the output state same as before, like alpha h plus beta v kind of thing? So can I write the output state like this in the second case also? It depends on phase, even if more than one inputs are there, but is it pure? Yeah. If they have constant phase difference, then it will be pure. But in general, the thing is, the lasers are different, right? So this is not a coherence for, there is no phase relationship in general, right? Because these lasers are emitting randomly, these lasers is also emitting randomly, right? This lasers one is don't know that after 5 second laser 2 will emit. Like if I emit, suppose first photon is going here, after this is your first photon from laser 1, and the first photon from the laser 2, it may come after 2 seconds, and the second one may come after 5 seconds, like 2 5. The gap is not same for the laser 1 or laser 2. I mean, just simply I am telling, so they are not correlated. Like the phase is random kind of. If the phase is not random, then it's okay, right? As you say. Yeah, it depends on the phase, exactly. But experimentally, theoretically you can make it, but experimentally it is not possible to like constant phase relationship between two different laser kind of. So here you cannot write the state like this, because alpha, beta, these are not constant. They are random kind. There is some phase kind of. Some alpha equals to some. You can write alpha equals to beta e to the power some I phi. Phi depends on time. So this is random kind of thing. Okay. So in this case, you cannot write the output state like this. Okay, this is not your output state. So this, because this is incoherent superposition, not a coherent superposition. So that means there is no phase relation between the fields coming from the two laser states. Between the field coming from two different laser source. If you can make the two laser source such that they have a definite phase relationship between the two, then obviously you can write psi equals to alpha h plus beta v. But experimentally it is not possible, so it is not a pure state kind of. So it, in fact, in this output you cannot write the state actually. So if you want to write the state, you cannot write the state. So that's why you need the mixed, I mean mixed state here, or density matrix. Why you need the density matrix? Because whenever you going to mixed state kind of picture, in pure state you have no problem. You can write the state. But whenever you have the output as a mixed state, you cannot write the state psi as like this, alpha h plus beta v. So you need density matrix, that's why. So you write the output rho, output of this, suppose output of this beam splitter, right? Output of the beam splitter is given by rho equals to, you write some mod alpha square hh. Suppose this beam splitter has ratio alpha is to beta, then hh plus mod beta square vv kind of thing. Because you cannot write the state like this, psi is equals to alpha h plus beta v, instead you write the density matrix in case of mixed state, because there is no phase relation, this is everything is random here. So this is your density matrix. Just like before, if alpha equals to beta equals to 1 by root 2, then obviously your density matrix will be 1 by 2 hh plus dv. And if you write, so this is the unpolarized light. Because in unpolarized light, you don't have any phase relationship. So this is your unpolarized light. And in this case, pure state, the first case, you can write this is your polarized light kind of thing. So this is your 45-degree polarized light you are getting output. So here your output is a 45-degree polarized light. If alpha beta equals to 1 by root 2, that means you are using 50-50 beam splitter. So your output will be 45-degree polarized light. And in the second case, your output will be unpolarized light. Understand? So you can take here, like you can write the matrix from. So in matrix, what will be write? So this is 1 0 0 1, right? Fine. Anyone has any doubt here? I will just wait 1 minute. If you have any doubt, you can just ask. Just write in the chat. I cannot hear that. Just write. I am coming in just 2 minutes from washroom. Like, The maximally mixed state, like it will come later. I think this entropy thing, some von Neumann entropy, some S is equals to log rho kind of thing. From there, mathematically you can derive. But in general, if your density matrix is proportional to the identity matrix half of, then you can call it the maximally mixed state. So now do the third problem of the assignment. Like so, you are given the density matrix 2 cross 2 rho is given by this. So you have to verify which of the following statement is correct. Rho is a density matrix. Is it a mixed state or Hermitian or pure state, whatever. So rho is given by this. So you have density matrix rho is given by 1 by 4, and this is root 3 by 4 e to the power I5. Here you have root 3 by 4 e to the power minus I5, and here is 3 by 4. This is your 2 cross 2 density matrix. Now let's check the properties of the density matrix step by step. So first one, you have to check is a density matrix or not, or whether it's a pure state or mixed state, whatever. So first thing, check whether rho dagger is equals to rho or not. So this thing is whatever. So this will be given by 1 by 4. This is given by what? Root 3 by 4. So you have to take the star of these things, right? Conjugate of this root 3 by 4 e to the power I5. Here this will be 3 by 4, and here you have to take the conjugate of this. So this is root 3 by 4 e to the power minus I5. So this is your root dagger. So this is equals to rho. So root dagger is equals to rho. That means rho is Hermitian, as any density matrix would be. Second thing is you have to check the trace, right? So check the trace of rho. Trace of rho would be given by 1 by 4 plus 3 by 4, right? So this is 4 by 4 equals to 1. So trace of rho is 1. Rho is Hermitian. So that means rho is a valid density matrix, right? These two are important. So these two implies rho is a valid density matrix. So what are your options like? So first one is correct row is a valid density matrix. You have to identify which is incorrect, right? So first one is correct. Row is a valid density matrix. Second one we didn't check yet. Row represent mixed state or pure state, that we have to do. Third one, row is Hermitian. It is correct also. And fourth one, it represents a pure state. So we have to check now whether it's a mixed state or pure state. So for that, the thing is you have to find the trace of row square, right? So find the row square. What will be the row square? Row square will be given by 1 by 4 I5 3 by 4 to the power minus I5. This is 3 by 4. To the power I5. Multiply, what you will get? So this is 1 by 16 plus this will be given by 3 by 16. The second term is, what will be the second term? So this is like root 3 by 16 e to the power I5, right, plus 3 root 3 by 16 e to the power I5. And the third term is given by root 3 by 16 e to the power minus I5 plus 3 root 3 by 16 e to the power minus I5. And here you will get what? 3 by 16 plus 9 by 16, right? So your row square is given by what? rho square will be, so first term is 4 by 16, here it is 4 root 3 by 16 e to the power I phi, this is 4 root 3 by 16 e to the power minus I phi, and it is 12 by 16. So your rho square is 1 by 4, this is root 3 by 4, e to the power I phi, this one is root 3 by 4 e to the power minus I phi, this is 3 by 4. So your rho square is given by this, and your rho was this, so rho square and rho are same, right? Your rho was this, and your you got the rho square like this. So you can write rho square equals to rho. And also you can check that trace of rho square. You check the trace of rho square. So this is 4 by 4 equals to 1. So everything implies that it is a pure state. Right. So this is a pure state. So all the options. So rho is a pure state also. So option B is correct. Rho is not a mixed state. Fine. So rho cannot be a mixed state. Any doubt in this problem? Okay, fine. If no other problems, so let's do another problem related to this density matrix. So suppose consider you a pure state. Now consider next question. You consider a pure state. So this may be an important problem. So consider this is what happens. Consider a pure state, and the state is given by psi theta. Now write this as 1 by root 2 of plus e to the power I theta So, right? So this is your pure state. It is given that this is a pure state. I mean, whenever you are writing psi like this, it's implicit that it's a pure state. Right? If it is a mixed state, then you cannot write a state like this, psi theta and that thing. As I described above, right? You have to write the density matrix. You can write, but it will be only a symbolic kind of thing. So you have to write now. The thing is, you have to write the density matrix. So first thing is write the density matrix. What will be your density matrix here? So rho is given by psi theta s theta, right? So if you do this, what you will get? Okay, now to make your life simpler, just do this now. You know this up means what? In matrix, this up spin means 1 0, right? And down spin means 0 1. So first you write the psi theta in the matrix form, that will be easier. Psi theta you write 1 by root 2 1 0 plus e to the power I theta 0 1. So you write this as like, so what will be your state here? So first one is 1 by root 2 and second one is e to the power I theta, right? So this is your psi theta. So density matrix, so this is your psi theta, and it is like this 1 by root 2 e to the power I theta. This is the bra, then k will be given by 1 by root 2 e to the power minus I theta, right? Now multiply these two, what you will get? First term is 1 by root 2 into 1 by root 2, right? Second one is this into this, so 1 by root 2 e to the power minus I theta. Third one, this term is e to the power I theta 1 by root 2, and here e to the power I theta into e to the power minus I theta. So your rho is given by, this is 1 by 2 sorry, I am doing something. So 1 by root is the bracket, so there will be 1 by root 2 here also. Sorry. Okay, fine. So there will be another 1 by root 2 here also, and here also. Okay. Fine. So this is your half. This is half e to the power minus I theta. This is half e to the power I theta, and this is 1. Sorry, again this is root 2, root 2, so this is half. So your density matrix rho is given by half of 1 e to the power minus I theta e to the power I theta 1. Okay. You can check this is a pure state or not, just square and take the trace of rho square and check everything. That I'm not doing, you can do. Here also you can just for simplicity you can check trace of rho is equals to 1 by 2, 1 plus 1, this is 1. It's a valid density matrix also. And rho dagger is rho also, right? Equals to rho. So this is a valid density matrix. It is just for cross checking whether you are correct or not. Now we have to calculate rho is equals to 1 by 2 pi integration 0 to 2 n pi. N is some integer can be. This is 2 n pi. Or you write n pi for simplicity, not simplicity. You write 2 n pi, it's okay. So you have to calculate 1 by 2 pi integration 0 to 2 n pi rho d theta. And rho is given by this. You already calculate the rho, right? Half of 1 e to the power minus I theta divided by I theta 1. Now we have to calculate this 1 by 2 pi integration 0 to 2 n pi rho d theta, where n can be any integers 1, 2, 3, 4, whatever. Just try doing, I will do now. Just try to do, I will just wait few minutes. And tell me the answer you are getting for n equals to 1. Okay, the root prime, make it root prime. So for n equals to 1, the root prime you are getting, just tell me. Psi. So your state vector is psi given by this, right? Psi theta is 1 by root 2 e to the power I theta by root 2, right? So this is your suppose bra, then kth, this is kth, then bra will be given by what? If you want to write this one, this is given by this dagger, right? So you have to take the transpose and the conjugate also, right? So you have to take transpose plus conjugate. So if you take the transport of this, then row will become the column one, like this. Row will become the column, right? And you have to take the, is nothing but this, you have to take the star and make it column, right? So for simplicity, right, make the conjugate and row to column, right? So make the row to column and take the conjugate one, right? So that's what I am doing. Okay, fine. Okay, let's do the calculation. So I have to integrate from 0 to 2n pi rho d theta, right? And you got the rho is like this. So actually later I will put n equals to 1 and find the rho prime. So this is 1 by 2 pi integration 0 to 2n pi, and your rho is given by half of 1 e to the power minus I theta e to the power I theta 1 d theta, right? So this is a matrix integration, right? So you have to integrate each element of the matrix, right? So this is 1 by 2 pi. Now this half is coming, so make it 1 by 4 pi. So this is 1 by 4 pi, and the matrix is now, first term is integration 0 to 2n pi 1 d theta. Second term is integration 0 to 2n pi e to the power minus I theta d theta. Here you have integration 0 to 2n pi e to the power I theta d theta, and here you have again 0 to 2n pi 1 d theta, right? So this is your density matrix, not density matrix, integration of density matrix. Now 1 by 4 pi, the first term will give you integration 0 to 2n pi d theta. So this is nothing but 2n pi, this is 2n pi, right? So third, this term I have to calculate 0 to 2n pi. So can anyone tell what is the value of this integration? Integration 0 to 2n pi e to the power minus I theta d theta. What is the value of this? Similarly, what is the value of this also? 2n pi e to the power I theta d theta, and this is 2n pi. No problem. So I have to find the values of these two terms. This integration value I need. So 0 to 2n pi e to the power both of these, so one is plus, one is minus. E to the power plus minus I theta d theta. What is the value of this integration?
0.
1 minus e to the power minus 2n pi. Well, let's check. This is nothing but, so what is this? 1 by plus minus I will be down, e to the power plus minus I theta 0 to 2n pi, right? This is minus plus it. This is minus plus I. So you multiply I on up and down. So this is I here, I square is here, right? So I square will give minus 1. So plus will become minus, minus will become plus. This is minus plus I e to the power plus minus I 2n pi minus e to the power 0. E to the power 0 means 1, right? Now e to the power 2n pi. What is the value? So this is e to the power I theta means cos theta plus I sin theta, right? So e to the power I 2n pi means cos 2n pi plus I sin 2n pi. Now sin 2n pi is, everything is even, right? It is 0 always, right? For n equals to 1, 2, 3, whatever, it is 0. So, and cos 2n pi is what? This is minus 1 to the power 2n, right? So this is always 1. Understand? Because cos n pi is what? Cos n pi is given by minus 1 to the power n, right? So cos 2n pi is given by what? Minus 1 to the power 2n. So this is minus 1 square to the power n. So this is 1 to the power n means always 1. E to the power I 2n pi is always 1. So this is minus plus I 1 minus 1. So this is 0, right? Just check, is it okay? Write in the chat if you have any doubt. Yeah, it's 0. Parvati is correct. If you have no doubt, then I will proceed. Just check last time. So Parvati, you can ask in the chat. I think I cannot hear. Whoever has any doubt, just write in the chat. There is some problem in the microphone, I think. Okay, fine. So the integration rho prime is given by, what was your rho prime? So rho prime was 1 by 4 pi. So this is 1 by 4 pi. This was 2n pi. This integration is 0. This integration is 0. This is 2n pi. Right? 2n pi you can take it out, right? So this is 2n pi by 4 pi 1 0 0 1. This is n by 2. This is nothing but the identity matrix, right? I 2 cross 2. And for n equals to 1, 2 or whatever value you can find. So n equals to 1, rho prime is nothing but half of identity matrix. So now the another interesting problem, like this is also important. This is kind of experiment related. So like suppose there are two persons, so two people. So this is suppose some experimentalist. So experimentalist A and another person named B. A and B, two experimentalists are doing experiment. Okay. Now what A do? A is preparing. A has some atoms, right? And all the atoms are in states given by psi A. Okay. Psi A given by 1 by root 2 half plus this down one. So the experimentalist has prepared, says, suppose they have some silver atoms or whatever. All the atoms are in state psi A. Okay. So atom 1 has state psi A. It means like atom 1 is in state psi A, atom 2 is in state psi A. Suppose there are hundreds atoms, so atom hundreds also in psi A state. Okay, so atom number 100 is also in psi A state. So each atom is in state psi A for this person A. And for person B, the thing is that he has prepared, he also has hundreds atom, but 50 are in, they mixed, not in steps. Like, so A has hundreds atom, total is 100 suppose. So each atom A prepares in state psi A. The difference is B has also hundreds atom. Okay, suppose total hundreds atom, but B prepares a mixture. Okay, B or C, whatever, prepares a mixture of these 100 atoms. Prepares a mixture of these 100 atoms in which half are in state up and half are in state down. So that is the difference. A has hundreds atom and all the hundreds atom are in state psi A, and B has also hundreds atom, but he made a mixture. Okay, mixture means suppose 50 atoms he choose in up state and 50 atom he choose in down state, and B mix them both. Okay, I think it's clear, right? Okay, now you have to tell me like which one is the pure and which one is the mixed state. I mean, you have to tell experimentally how, I mean, how you will perform the experiment so that you can distinguish the atoms of A and B. Suppose you have this box, you have these A atoms coming to you, and you have another box, B atoms. I mean, all the hundreds atom inside. Okay, but this is from B. There is also hundreds atom, but these are from A. There is also hundreds atom, but these are from B, and both are coming to you. How can we distinguish the two stream of atoms? Question is how you can distinguish A atom stream from B, and how you can distinguish with experimentally, not theoretically. Okay, which experiment you will perform? Or, I mean, what kind of measurement you will do? What measure? I mean, you have to measure something that will tell you that this is A, this is B. So what you will measure? Understand? I think the question is clear. If you have any doubt in the question, then you can ask. Okay, in between, just complete the last one. Then I will come back to these questions. So first 4 questions I will do. Next 4 tomorrow someone will do. So last one I will come back to this A and B problem. Just finish these things. Okay, so the fourth one is what? You have to write the state corresponding to theta equals to pi by 2 and phi equals to minus pi by 2, right? The two level superposition state that corresponds to point this on a broad sphere. Okay, this is the small one. Okay, just do it here. Theta equals to pi by 2 and phi equals to pi by 2, right? Sorry, minus pi by 2. You have to write the broad sphere state. So you know that theta phi is given by cos theta by 2 0 plus e to the power I 5 sin theta by 2 1, right? This in general the state broad sphere in broad sphere. Now just put theta equals to pi by 2 and phi equals to pi by 2. We'll get the answer. Okay. So this is pi by 2 minus pi by 2. This state will be given by, if you put, you will get 1 by root 2. This is 0 minus I 1. Okay. 1 by root 2, 0 minus I 1. So the last one. Okay. Okay. Now just go back to the experimentalist A and B questions. Okay. If you have any doubt on this state preparation of A and B, you can just ask now. So we have to take some measurements so that you can identify the atoms coming from A and the atoms coming from B. So what you will measure? Yeah, spin, but which spin? We'll measure spin, that's okay. But how? I mean, which spin you will measure? Vertical or horizontal? I mean, this which vertical spin, horizontal spin means in which direction, like X, Y, Z direction. I mean, suppose you measure the spin in Z direction, right? Just look at the state, right? Suppose here you measure, right? Here you suppose you try, you measure spin in z direction. Okay, so if you measure spin in case of A atoms, suppose this box, okay, here if you measure spin in z direction, what will be the outcome? You will get 50% of time up and 50% of time down, right? Because you look at the state, so probability of in up state is 1 by root 2 square, because here the probability is 1 by root 2 square, that means half, and here also the coefficient is 1 by root 2, right? Both in up and down, right? So probability is same. So this is also 1 by root 2 square, that means half. So if you measure spin in z direction here in A atoms, you will end up getting half of the time half up spin, half of the time down spin. Like up spin means you will measure h cut by 2 half of the time, minus h cut by 2 half of the time, right? If this is a spin half particles, assuming these are spin half particles, so this is the thing. Now you measure spin in z direction in here, okay? Measure spin in z direction. What you will get if you measure spin in z direction here? Look, this up or down state, these are the eigenstate in z direction, right? I think you have studied, right? S is given by h cut by 2 sigma. So this up and down state, how you will get? This S means Sx, Sy, Sz, all these things are there, right? So if you Sz apply on up state, you will get h cut by 2 up, right? This is the eigenstate of Sz operator. Sz acts on down state, gives you minus h cut by 2 down state, and these are the eigenvalues, right? So up down means you are already in z direction. Now we measure spin in z direction in first case, that means in case of at A atoms, you will get half of the times up, half of the times down. Now in case of B atoms, if you do the same measurement, like you are measuring the spin in z directions, what you will get? Here also you will get half of the times up and half of the times down, because it is a mixture, and mixture is how we make the mixture, half of 50 atoms in up and 50 atoms in down, right? If you measure each atoms, so you will get half of the times up and half of the times down. So you cannot distinguish the two systems, like two atoms A or B, by measuring the spin in z direction, right? So you cannot distinguish the two systems by measuring spins in z direction. Okay, so you have to do something else, right? Because both will give you half of the time up and half of the time down. You have to measure something else. What you will measure? Yeah, Z or vertical horizontal. This will not able to distinguish. So you have to measure some other spins. Just look at the state of that A atoms. Okay, then you will understand. I am telling you have to measure the spins. But which spin? Not in Z direction, right? You see, if you measure spin in Z direction, you will not be able to distinguish, because your measurement result will give you 50 atoms in up and 50 atoms in down in whatever the situation is. Yeah, x direction. Yes, correct. So you have to measure spin in x direction, right? Why x directions? Because just look at the state psi a. So psi a is given by 1 by root 2 up plus down. Can you recognize this state? This is one of the eigenstate of Sx operator, right? So you have this Sx operator given by h cut by 2 sigma x, right? So this is h cut by 2 0 1 1 0. So if you find the eigenstates and eigenvalues of these operators, then what you will get? This has eigenvalues. This will give you eigenvalues lambda equals to plus minus h cut by 2 and eigenvectors will be 1 by root 2 1 plus minus 1. So Sx has eigenvectors 1 by root 2, this is up plus sorry. So it has eigenvectors 1 by root 2 1 minus 1 with eigenvalues h cut by 2. So this is 1 plus 1 with eigenvalues h cut by 2 and 1 by root 2 1 minus 1 with eigenvalues minus h cut by 2. So psi state is what? This is the eigenstate in the x direction, right? So nothing but this is nothing but the spin state in x direction, right? So now if you measure the spin state in x direction, so instead of measuring the spins in z direction, now you measure the spin in x directions, okay? And one thing is that the spin state in z direction, suppose you write the up state, right? Suppose the down state is given by what? 0 1. 0 1 always you can write like this: 1 by root 2 1 by root 2 1 by root 2 minus 1 by root 2 of 1 by root 2 minus 1 by root 2. If I write psi plus minus, then the eigenstate in z direction, the down eigenstate in z directions, that means 0 1, you can always write as a superposition of the eigenstate in x direction, right? So this is 1 by root 2 psi plus minus 1 by root 2 psi minus, right? Similarly, the eigenstate in up, like eigenstate in z direction, that the up eigenstate in z direction, we can write like this also: 1 by root 2 psi plus, sorry, this bracket is not here, okay? So this will be 1 by root 2 psi plus plus psi minus, okay? You can always like this, okay? Now do the measurement is x directions. If you now do the measurement is x direction, what will happen? So this is a and this is b. Now you measure x. So from A the state is eigenstate in x direction, right? A state is nothing, all the atoms in A has eigenstate in x direction, right? So if you measure x direction, measure spins in x direction, what will be your result? You will always get h cut by 2, right? Because all the atoms are in plus eigenstate, right? Plus h cut by 2 eigenstate of x, Sx operator, right? And if you measure, you will always get h cut by 2 100% of time, right? Now in case of B, what B has? B has 50% up and 50% down, right? And the up state I showed you, up state means 50% up, and up state you can always write as a eigenstate of, I write x, right? Eigenstate of plus and minus eigenstate of x operator, right? Up eigenstate you can write 1 by root 2 psi plus x minus, psi plus x plus psi minus x. Down one you can always write 1 by root 2 psi plus x minus psi minus x. So B has 50% up and 50% down, right? Now you measure the spin in x direction, right? If you measure the spin in x direction, it doesn't mean you will always get 100% plus h cut by 2, right? There is also probability of getting minus h cut by 2 also here, right? Because these terms are there. If only psi plus is there, then it's fine, 100%. But here psi minus term is also there. So it's not that you will always get 100%. Not always you will get 100% h cut by 2, 100 plus h cut by 2, okay? If you measure spin in x direction in case of B. But in case of A, you will always get 100% x. So that's how you can distinguish the A and B case. If you have any doubt, just ask. Like similarly, if you have some unknown state, suppose some unknown state, unknown psi state you have. Now you measure Sz, okay? If you measure Sz, what you will get, suppose you are getting plus h cut by 2 and minus h cut by 2, you can get, right? And if you again measure the down, like minus h cut by 2 means this one you are getting here, you are getting this one here. If you measure here is x, okay, what you will get? You will get plus h cut by 2 again and minus h cut by 2 again. This has probability 0.5, this has also probability 0.5. These don't have probability 0.5, this may not have, okay, because this your state is unknown and you are measuring Sz, and if you measure h set, you will get h cut by 2 sometimes, if you may get h cut by minus h cut by 2 sometimes, and in minus h cut by 2 if you measure hx again, then you will get, now you will get with half probability plus h cut by 2 and minus h cut by 2. Now we can certainly tell the probability is half because of this 1 by root 2 factor. The down state you can always write like this: 1 by root 2 psi plus x, 1 by root 2 psi minus x. Okay. Anyone has any doubts? In this problem, everyone understand it? Gulab, can you just write in the chat if you have any doubts? Fine, no problem. Okay, so this session I will end here. So last 4 problems and some other concepts and problems will be discussed tomorrow by someone else. You have the time, right? Tomorrow from 6 to 8. If you have any doubts regarding the topics related to these 2 previous state or the next 4 questions related, you can ask me. Okay. So okay, fine. I next Monday I will meet again. Okay, with the next assignment. Do you have any books to understand the quantum circuits and how the value follows from one gate to another gate? Books I cannot recommend now. I usually watch some videos available in YouTube also, like, and some books are there, but I don't remember the name now, so I cannot tell. Just watch some lectures in YouTube, okay? That will be better and fast. And take some general book of quantum computing. Every book will have. I don't remember that's why the name. Which book is followed? Which book? I think Sarah's already tell in the course, right? Introduction. Just take any quantum computing book. Everywhere these things will be there. Okay. Don't worry. Okay, fine. I will end here. Next Monday we'll meet. Okay. And if you have any doubts, just next Monday you take with your doubts. Okay. Fine. Okay, fine. I will end here. Bye.
Bye.